All right, chapter 6, section 3. This is the last section for your quiz on Thursday. Again, please start studying because 6.1, 6.2, and 6.3 have a lot of information in them. So we covered angle bisector, we covered perpendicular bisector. Now we're going to cover median and altitudes. So, median. Median is a segment from the vertex to the midpoint. Okay, median is from the segment, is from the vertex to the midpoint. Median, do we know what the word median means, just by definition? Okay, median is the center, so hopefully you guys covered in middle school the three things: mean, median, mode. Mean was the average, median is the middle number, mode is the one that happens the most often. So when you're thinking of a median, or you could think of a median as if you're driving, the median is always in the middle. So when I'm looking at the median, I'm going from the vertex to the midpoint. Okay, vertex to the midpoint. So that means I am cutting my segment, looking at segment AB in half. Okay, that's where I'm stopping. So this point right here is going to be my midpoint. Let me grab a color. This point right here is my midpoint. Okay, so that red line is called my median. There are 3 medians in a triangle. So showing you where all my medians are. That's one that they're giving you. Again, another one, I'm starting on my vertex and going straight across to where it makes these segments congruent because it's going to the middle of my segment. And then I have one more median, which again goes from my vertex to the middle. If that's the middle, let me kind of draw it a little straighter. Let's say it's right here. So now these segments are going to be congruent. Okay, so we're doing where they intersect, the point of concurrency. Yes, this one also has a name. So this point of concurrency where they meet, if I drew my lines as perfect as possible, they all would meet right here. This point is called centroid. Okay, that point is called my centroid. So medians have to do with centroids. All right, what is a centroid? That is the point of concurrency of my medians. Okay, so we've seen a couple of these and known a lot of vocabulary. The medians have to do with centroids. A couple of things that we should know. I'm going to write them at the top. We have already worked with perpendicular bisectors. Perpendicular bisectors are for what? Perpendicular bisectors go with my circumcenter. Okay, in my circumcenter, there are 3 places where it could be. It could be in my triangle, it could be on my triangle, or it could be outside my triangle. When it's in my triangle, what kind of triangle is that?
Right is on top.
So right is on.
Is it acute?
Good. Acute is in.
And then obtuse is out.
And then obtuse is out. Okay, so we had AI, right on, and OO. Okay, that's for my perpendicular bisector. Then I have angle bisectors, which are incenters. It's my incenter. Okay, that's the point of concurrency when I'm dealing with angle bisectors. And these are always inside. Okay, so when I'm looking at centroids, centroids are also always inside the triangle. All right, another thing, centroid is also called center of gravity. because it is the point where the triangle region will balance. So again, if you're looking at this diagram, if you put a pencil on that triangle right in the center, it would balance there. The paper wouldn't fall over, it'll just be balancing. Okay, so you could also know it as, that's the center of gravity. Your centroid is the center of gravity. Okay, so it's that point on that triangle. All right, centroid theorem. We will be working with fractions. Okay, yes, we are working with fractions, but they're not hard. So when you are working with fractions, something you need to know regarding your medians. Okay, the centroid of a triangle is 2/3 of the distance from each vertex. So if I'm looking at this diagram, from the vertex, there are 3 points from the vertex to my centroid. Remember, they're not going all the way across. So if I'm looking at this, I'm going to go ahead and I'm going to write 2/3. This is going to be not in a highlighter. This is 2/3 right here. This is 2/3. And this is 2/3. So I'm only going from my vertex to my centroid, from my vertex to my centroid, from my vertex to my centroid. That does not mean they're equidistant. They could be different measurements for all 3 of those. Okay? So from the vertex to the centroid is 2/3. So that means from my side to my centroid, those are all going to be 1/3. So yes, we are working with fractions, but they are going to be consistent fractions. So I'm just going to go ahead and make a note of that underneath it. From my vertex to my centroid, it is 2/3 of the whole median length. And then from my centroid to my midpoint, it's 1/3 of, again, the whole median length. So you should be able to solve for what they're asking for. Okay, so vertex to centroid is 2/3. And yes, we should know what the vertex is. It's the point where they meet. And then from my centroid to my midpoint is going to be 1/3. All right, so looking at this example, it says triangle LMN. In triangle LMN, S is the centroid. RL is 21, SQ is 4. So just highlighting RL, this entire line right here is going to be 21. And then SQ is 4. What do they want me to find? Find LS. How would I find LS? Yes. No, I'm not subtracting anything. So 4 is on a separate line. 4 is going to be on this line right here. So keep in mind, you guys need to remember, these lines are not the same measurement. So this could be a different measurement than this one. This is going to be a different measurement than this one. They're not the same. They're not going to be the same. Jonah?
You find what 2/3 of 21 is?
Good. I'm going to find 2/3 of 21. Okay, so how I'm solving it for A. You could think of it as LS. That's not an S, that's a 2. LS is 2/3 of RL, and RL is 21. So I'm multiplying these two. So if I multiply them, I'm going to get 14 because you're putting it over 1. You could cross simplify, LS equals 14. What's another way I could solve this? Yeah. I could totally do 21 divided by 3. Because remember, you could think of it as cutting into 3 pieces. 21 divided by 3 is going to give me 7. So this segment is 7. This segment is 7, and this segment is 7. And then you could think of it as, okay, I have 2 out of my 3 parts. So I could do 2 times 7, and that will also give me 14. So yes, even though we're working with fractions, you could just divide it by 3 and then multiply what they're asking for. So now, if I'm looking for NQ, how would I solve for NQ? They're giving me only piece of it. They're saying a part of it or 1/3 of it is 4. How would I find the total? Yeah. I can take it and say, okay, remember, if 1 out of those 3 parts is 4, that means this other part has to be 4, this other part has to be 4. So yeah, you could totally do 4 times 3. And if you multiply correctly, your answer should have been 12 for the entire thing. So you could think of it as, yeah, I'm dividing by 3 or I'm multiplying by 3, depending on what they're asking me. So these questions should not be difficult. Yes, we're dealing with fractions, but they're consistent. They're not going to give you different numbers. It's either 2/3 or 1/3. Okay, questions on this one? Okay. All right, looking at example number 2, it says a sculpture shaping a triangle piece of iron that will balance on the point of a cone. At what coordinates will the triangle region balance? So if they're asking for a specific point that is balancing, okay, a specific point that is balancing my center of gravity, that's what I'm trying to find. So I know I'm dealing with centroid. And with my centroid, I have to find my median, which is I have to find my midpoints. So it's graphed for me. I'm going to come over here to the graph, and I have to find my midpoints, because remember, it's the midpoint to the vertex. That's what my median is. Yes.
Oh.
Yeah. What's the midpoint formula? Yeah.
X1 plus x2 over 2.
Good. You're just adding your 2x values, dividing it by 2, then adding your 2y values and dividing by 2. So we're going to go ahead and solve these. I'm going to do 6 plus 10 over 2. And then I'm going to do 6 plus 7 over 2. What's my midpoint for my top one? Anyone solve it? 8 and 6.5. So I'm going to go ahead and graph it. 8 and 6.5, which is right here. So I'm going to go ahead and take that and connect it to my vertex. That's a little, I'll do this one. Connect it to my vertex right here. Yes.
Didn't you also just see where it intersects?
Well, I have to draw my medians to see where they intersect. I'd have to draw my medians first to see where it intersects. Because it has to be the midpoints of the line. All right, looking at the next one. I'm going to go ahead and take 10 plus 8 over 2 and then 7 plus 2 over 2. For this one, I'm going to get 9. And then 9 over 2 is going to give me 4.5. So 9 and 4.5, which is right here. And then I'm drawing that to my vertex, which is right here. And then doing the last one, I have 6 plus 8 over 2, 6 plus 2 over 2. I'm going to get 14 over 2, which is 7, and 8 over 2, not 6. Let me erase that. This should be 4. So 7, 4 is right here. And then again, go ahead and connect it to the vertex. So if I'm looking at this graph, my centroid, okay, is right in the center. So my points for my centroid, I'm going to go ahead and write them right here, is going to be 8, 5. Those are my coordinates. So yes, this is a lot of work. However, there is a trick to it. I'm going to go ahead and show you guys the trick. It'll save you a lot of time. So please remember this little trick. It's definitely easier. So trick to this is I'm going to go ahead and take my x values, all 3 of my x values. I have 6 plus 10 plus 8 divided by 3. And I'm going to take my y values, 6 plus 7 plus 2 divided by 3. I'm then going to get 24 divided by 3. And if I add them, I'm going to get 15 divided by 3. And yes, I can simplify that. If I simplified it, what would I get? 8 and 5. Isn't that the same answer we got after I graphed them?
So you're just finding out.
Yeah. So I'm finding the center point for them. All right, now that we did centroid, we're going to go ahead, centroid using our medians, we're going to go ahead and look at altitude of a triangle. So an altitude of a triangle is the perpendicular segment from the vertex. So perpendicular segment to the vertex, okay, perpendicular segment from the vertex to the line containing the opposite side. So every triangle has 3 altitudes. An altitude can be like in center, it could be inside, outside, or on the triangle. So when I like to think of the word altitude, first thing to me, or first thing in mind comes is like a plane. Like, you know, whenever you're on a plane, they say, oh, we're at a certain altitude. That's the height of the plane to the ground. Okay, so altitude is always taking that perpendicular line from the highest point of that triangle, looking at it in any direction, to the floor. Okay, so you could think of it that way. I know that might sound confusing, but after we look at it, hopefully that should make more sense. So the altitude for Q to PR. So again, you're looking at it the highest point all the way down, that makes that 90-degree angle. This one is outside my triangle because I'm not making it a diagonal line. I'm just going straight from here down. So if you were to flip your paper around and draw these triangles, the altitude is from the highest point straight down. So the altitude straight down, the highest point all the way down. Okay, that's what my altitude is. So looking at it, the point where they intersect, your altitudes intersect, is called your orthocenter. So point G is your orthocenter. Okay, lines containing the altitude of a triangle are concurrent, and that point of concurrency is your orthocenter, and that's using the altitudes. Okay, so if I'm looking at this diagram, the lines containing AF, BD, which is right here, and CE meet. Okay, they meet at point G, which is considered my orthocenter. So I'm going to highlight that point. This point is my orthocenter. All right, location of the orthocenter. Location of the orthocenter depends on the type of triangle. So if I'm looking at this triangle, similar to in-center, if I'm looking at it, it's very similar to in-center, where if you have an acute triangle, it is inside your triangle. So if you're looking at this diagram, this point right here, P, is my orthocenter. So same thing, it's acute. Inside, it's AI. Looking at a right triangle is on the triangle. Okay, so this one's again similar to in-center, it's right on. keep in mind if you're looking at this one, okay, this line is perpendicular to my vertex. And these, because it's a right triangle, it's already perpendicular. So that means my point, my orthocenter is going to be right there on the vertex. And then obtuse is outside my triangle. So if I'm looking at it, you can see that point P is outside. Okay, so some students are like, why is it outside? If I were to draw all of these within this triangle, it can't work. Okay, it has to be a straight perpendicular line. So that means this line, okay, this has to be perpendicular. If I drew this inside my triangle, there's no way that it's going to be perpendicular. So I need to continue this line where it is going to make a 90-degree angle. So same thing with this one. No matter where I draw this vertex to the side, it would never be perpendicular. So I need to continue this line and draw it to where it's perpendicular. And if it doesn't meet anywhere, you need to continue those lines. Okay, so if you're looking at it, it's going to meet right here at point P. This is what makes it perpendicular at that point. Okay, at that point right there. So looking at example number 3, it says find the orthocenter of this triangle with those vertices. So first thing you have to do is graph it. So graphing it, I have -3, -4, which is right here. This is x. Y is -3, 4. Here's my y. And z is 5, 4. Here's my z, going ahead and connecting the dots. Oof. Drawing them as straight as possible. All right, now I have to go ahead and let's understand a couple things before I start. Is this a right triangle? Yes. So I know right triangles, orthocenter is on the triangle. Okay, so looking at this triangle, a couple things we know. Yes, it is a right triangle. So what is that telling me about YZ and YX? That is telling me YZ, or I'll put it up here so you guys can see a little better. YZ and YX is an altitude. What does that mean? If I'm looking at this, in order to draw it, this is my altitude. Same thing here, this is my altitude. So we could already kind of see where they're intersecting. Next thing is I have to find my altitude for my third side. Okay, remember, with altitude, it's from the vertex to a perpendicular line of the other side of the segment. So I'm starting from this vertex right here, and it has to make a 90-degree angle. If you're looking at it, the slope of my blue line is 1, 1. Okay, it's positive 1, 1. So that means the slope of my next line is going to be negative. So that means I'm going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and I'm stopping right here. So this red line is going to make perpendicular line. And this is my third altitude. Okay, and where do all of those altitudes intersect? They intersect right here on the vertex at 3, 4. -3, 4. So that is my ortho center. So a couple things you should know. If it is a right triangle, it is your ortho center is located at the right angle vertex. Okay, this is my right angle and this is the vertex right here. All right, questions on this? All right, let's go ahead and go to the last slide. This has everything. So this is putting everything into perspective and understanding what everything is. So I'm going to go over it section and section. We have perpendicular bisectors. Perpendicular bisectors go with circumcenter. That means it is perpendicular to my side and my sides are going to be congruent. It's bisecting it. So when I'm looking at it, what is equidistant? Yes, there is something equidistant here. The vertex are going to be equidistant. My vertex to my circumcenter is equidistant. So when I'm looking at this, they gave me those equidistant segments. If it is a perpendicular bisector, something again we should know, this is going to be congruent to this. This segment is going to be congruent to this segment. And this segment right here is going to be congruent to this segment right here. Those are my perpendicular bisectors. Okay, this is circumcenter. Now I'm going to go ahead and look at my incenter. With incenter, I'm dealing with angle bisectors. And with angle bisectors, for incenter, my sides are equidistant. So zooming in right here, they gave you those sides that are equidistant. And then I know that my angles are going to be congruent. So this angle is congruent to this angle. This angle is congruent to this angle. And this angle is congruent to this angle. So you could kind of see the difference between incenter and circumcenter. The two that we covered today, we have centroid, which deals with my medians. Okay. And from the centroid to the distance of the vertex is 2/3. So if I'm looking at it, something I have to know here. From my vertex to my centroid, that means this is 2/3, this is 2/3, this is 2/3. Again, they could be different measurements. That means this is 1/3, this is 1/3, and this is 1/3. So just highlighting, this is 1/3, and then these are 2/3. And then the last one that we covered is orthocenter. Orthocenter has to deal with your altitudes. Okay. So your altitudes and the center of that altitude is called your orthocenter, which is right here. So altitudes have to deal with those from your vertex to 90-degree angles. This is my altitude. All right, questions, comments, concerns. This slide is really good to see everything put together. All right, homework is on big ideas. The questions that you have to show work for is on Canvas. This is the last lesson before your quiz, which is on Thursday.